All right, this word problem is asking us to find out the temperature of a pot of chili over time. You're given a couple pieces of information about the temperature of the chili at certain times. And you also have some key points about the temperature in the kitchen was 72 and that hot foods are supposed to be served at 140 degrees. So what this boils down to is the fact that something that's cooling changes exponentially. The temperature changes exponentially. That's Newton's law of cooling. And so we use that here, and so we need to figure out what the points are in order to come up with our exponential equation that we're asked to do below. So let's look through this example so we can find out what our coordinate points are. Here we see that we have this read of 208 degrees Fahrenheit, and that was 1 minute after she took the chili off the heat. Then it says after 5 more minutes had passed, she checked the temperature again. There's now 175 degrees. So you can even see that more is italicized here. Those are going to help us find out what our coordinate points are. And so our first coordinate point is 1 minute after. And so 1 minute after, the temperature was 208 degrees. And our second coordinate point would be 5 minutes later. That implies that it's at 6 minutes and it's 175 degrees. So that's a key thing that a lot of students miss on this particular example. And once we have those coordinate points, then what we're going to do is we're going to start to do our finding exponential equations through 2 points process, which is the first thing is to make a table when you want to include x equals 0 in there. And so we have our coordinate points now, so we can make our table where we have 1, 208 and 6, 175. And then it says we want to amend the table with the y minus k column. The y minus k column is the part that comes from your asymptote. So that is the fact, or that comes from the fact that the temperature in the kitchen was 72 degrees. So the temperature of the chili is never going to be cooler than 72 degrees. So as you make your y minus k column, you're going to subtract 72 from each of those values. And if you subtract 72, that means you're going to have your value of 136 and then 103 if you subtract 72 from both of those values. Those are the values that we are then going to use to calculate the multipliers. That said, that's the next step. Calculate the multiplier from your y minus k column. So we look at this, we see that we have a gap of 5. So to find that multiplier, that multiplier is going to be the fifth root of what we call next over previous. So you do your 103 divided by 136. And when you do that, you get a value of 0.9459. And it does say to round values to 4 decimal places if needed. That would be 4 decimal places. And so include y equals in your answer. Now we know our multiplier. We know our asymptote of k is going to be at 72, but we still need to know the a, which is to find a by working backwards to find out what you get at x equals 0. So what you're going to do is you're going to take your 136 and you're going to divide just once. We just have to divide once by that 0.945 number. And you want to try to use your exact value as much as you can. You can use your graphing calculator to do that, I imagine. And so then you would get 143.7736 would be what you have for your value there. So that means our equation is y equals 143.7736 times your multiplier of 0.9459 to the x, and then you got to add your asymptote, which is 72. So there is our exponential equation through those 2 points for this pot of chili. What this equation tells us is the temperature over time. The temperature is decreasing. You have a multiplier of 0.9459. So therefore, we know it's decreasing, and you see that in your table. You see that in your values. And so that's the equation piece. And from here, it says we want to find the time that, since it was taken off the heat, how long until it actually cools to a temperature that is recommended by the FDA, which would be 140 degrees. And so you're going to use this equation and you're actually going to set it equal to 140. So 140, I'm going to do it over here actually, so I have a little space to do work. So 140 equals that 143, that whole decimal, and 0.9459 to the x plus 72. 2. And from here, what you're going to do is you're going to solve. So we're going to start by subtracting 72 on both sides. I'll do that in yellow, I guess, here. So we're going to subtract 72 from both sides, and that gets us to your 68. So you have 68 is equal to 143.7736 times 0.9459 to the x. And this is an exponential, so we are going to use logarithms, but not until we have only the exponential, which means you need to divide by that 143.7736 number on both sides, right? You need to you have to divide here by that 143 number, 143.7736. And you divide all of this because that's how you want to get your exponential alone. And when you do that, you get 0.4729. So we have 0.4729. You got a lot of decimals in these problems, but you got a graphing calculator, and so you just keep on working with it, keep on using them. You got those values stored in there. And so now that you have that, you're going to do the logarithm of both sides. So I'm actually going to shift this over this direction so I can finish this. And so you're going to do the log base point. So now the base of my exponential is this 0.9 decimal. So 0.9459 of your 0.4729 number. So you have to do the log base, so 0.4729, and that's when you do that, that gets you what x is equal to. That's going to cancel out your exponential. So this is the exact answer. And then you want to find out your decimal answer, so it's round to 2 decimal places, by using your calculator here. And depending upon which calculator you have, that might change how you go about evaluating this to get an actual decimal. But all calculators could use your change of base formula, where in order to calculate what x is, you would actually do the log of 0.4729 divided by the log of 0.9459, and that would equal what x is. So you can just do this on your graphing calculator, and no matter which kind of calculator you have, you can do that sort of work and it will get you the exact answer. So when I did that on my graphing calculator, I got a number like 13.47 if I round. I'm running out of space here, but x equals 13.47 minutes, right? And that would be what your solution is. So that tells you a lot of stuff going on in this problem, but finding these points is obviously step one, but that 5 more minutes is a key part of setting up your table. Subtract your asymptote, find your multiplier, use that to find out what the zero term is in that amended column, creates your equation. You can set it equal to the value you need, and then you just subtract, divide, and logarithm in order to be able to find that value.